Good morning. In this video, I'm going to discuss pumps. So we'll be solving the horsepower of a particular pump that is suitable for a particular application. So let me share the PowerPoint. Okay, so pumps, these are these are usually devices that move liquids. So unlike compressors, compressors are used for gases, pumps are used for liquids. So pumps are generally rotating equipment. As you can see, there's a motor over here, right here. Tapos, usually in front of the motor, there are there's an attachment that increases the velocity of the liquid. Okay. So let's see the mathematical equation used to calculate the horsepower of a pump. So a pump is an energy consuming device, no? So when you have an energy consuming device, when the when the efficiency decreases, the amount of electricity or horsepower that it will require will also increase, no? So the lowest horsepower correspond to 100% efficiency. And usually, that lowest energy requirement happens on an isentropic process or constant entropy. So, thus, the equation for pump efficiency is equals to Ws isentropic divided by Ws actual. Okay? So, when we perform an energy balance, no, on a pump, this is your pump. A general energy balance for a pump. Uh, Generally, we draw pump like this. Okay, so delta H is the general energy balance equation plus delta PE plus delta KE is equals to Q plus WS. So as you can see in the pump, generally the kinetic energy and the potential energy are negligible. And then since we'll calculate using the delta HS, the isentropic delta H, Q will also be equal to 0. So that's why delta H is simply equal to WS, no? As shown in these two equations. Okay. And then, siyempre, the efficiency should be always lower than 1. So, the equation for efficiency is Ws isentropic divided by Ws. Or, this is just the same as delta HS. Delta HS is delta H isentropic divided by delta H. So, this is supposed to be pump. So, pump efficiency are usually in the range of 0.7 to 0.8. Tapos, sa Aspen HYSYS, ang pump efficiency, ang default value niya ay 0.75. So let's take a look at this graphical representation of the pump, no? So on the y-axis we have the enthalpy H, this enthalpy H. Then on the x-axis we have the entropy S. So this is initial pressure, pressure 1. This is the isobaric curve, isobaric line, no? Tapos P2 is the final pressure. Ano? So when you have an isentropic process, constant S, this is the broken line represents the isentropic process, the reversible process. So as you can see, um, H2 prime, H2 prime minus H1 will give you delta HS. This is delta HS. And then on reality, the entropy increases. So when the entropy increases, this is the delta H. This is the actual delta H. And this is the actual delta H. So the actual delta H, as you can see, it's much bigger than the ideal delta H or the isentropic delta H. So that's why we calculate the efficiency as delta HS divided by delta H. Okay, so that's how you should remember, no, the logic for the efficiency of a pump should be delta HS divided by delta H. Okay, so next, in the case of a pump, you cannot use the steam table because the subcooled liquid data for entropy and enthalpy is not available on the steam table. Okay, so if you still remember your fluid mechanics, we usually calculate delta H in terms of change in pressure as delta P divided by rho. You still remember this. So basically this equation is coming from the definition of enthalpy, no? So if we start with the definition of enthalpy, H is equals to U plus PV, and then you get the derivative of this definition. We have DH is equals to DU plus PdB plus BDP. And then recall Peirce law. From the Peirce law, we have DU is equals to DQ plus DW, right? Peirce law. So this is definition of H. No, this is your Peirce law. Okay, and then the definition of DQ, diba DQ is equals to TdS. This is the definition of entropy, no? This equation. Tapos dW is equals to negative. So when you substitute du to this equation, it will become dh plus dq plus dw. And then when you substitute dq, this equation to dq, and you substitute dw to this equation, what will happen is you will have this dh is equals to tds, okay, minus pdb plus pdb plus bdp. I hope you can follow. Ano? And then these two will cancel out. So the simplified equation or the fundamental equation for enthalpy, fundamental equation of thermodynamics for enthalpy is equals to dH is equals to TdS plus BDP. I'm not sure if you're familiar with this fundamental equation for enthalpy. Now, if your process is isentropic, in an isentropic process, this term right here will become zero. So we are reduced with this equation. dH is equals to B dP. If you're going to integrate this equation, you will arrive at delta HS. Liquids have a constant molar volume. It's incompressible. So this equation will simplify to delta HS, no, is equals to B delta P. Okay. So make this equation part of your stock knowledge for pumps, no? Delta HS is equals to B delta P. And then remember that B delta P is equals to delta HS. Ibig sabihin, this is 100%. This is the isentropic work, no? Okay? These are the fundamental equation, ano? Ito yung ginamit natin. DH is equals to TTS plus B. Tapos, from the fundamental equation, if you still remember, you can derive the Maxwell equation. Ano? So, we're going to use one of the Maxwell equation to derive this equation. No? Kasi generally sa pump problem, you are also required to calculate delta T. It's supposed to be delta. So we're going to derive these equations. Ano? And also in pump problems in thermodynamics, you're also required to calculate delta S. So remember, you cannot use the handbook for pump because the data for subcooled liquid and subcooled water is not available on the steam table. So that's why you need to resort to this equation. Actually, you can find this equation on the handbook, ano, on chapter 4 of the 8th edition. You can find this equation. So first, let's try to derive this. We'll be using the, we'll be assuming that enthalpy is a function of pressure and temperature. Okay, so if enthalpy is a function of pressure and temperature, so we have this equation dH is equals to partial derivative of H with respect to T at constant temperature times dT, okay, plus partial derivative of H with respect to P at constant this is supposed to be constant. This is supposed to be constant temperature times dT. Okay. So this one, delta H, partial derivative of H with respect to temperature at constant V. This is simply Cp. No, that's the definition of Cp. Cp is partial derivative of H with respect to temperature at constant V. So yeah, we have that's where the first term is from, no? Doon yan galing. So pag in-integrate nyo, halimbawa Cp is constant, hindi siya temperature dependent, no? Usually ganun naman talaga sa liquid. So you will have this portion of the equation, Cp delta T. No? What about this term, the second term? So ito, we need a Maxwell equation, ano, to replace delta H, delta P at constant T. Partial derivative of H with respect to P at constant T. So using a Maxwell equation, these are the Maxwell equation. So what we can do is probably we will use the definition, ano, yung kanina, yung from H is equals to U plus PB. Tapos we have the fundamental equation. Diba the fundamental equation is DH is equals to TDS plus BDP. So in order to get this partial derivative of H with respect to P at constant T, what we do is we multiply this equation, this fundamental equation with 1 over dt. Multiply natin ng 1 over dt. So what we're going to get is yung partial derivative ng ano, kasi constant naman to, no? The partial derivative of H with respect to P at constant temperature is equals to T ds dt plus B. And then this is, I think this is a constant T, ano? For what? Yes, this is constant t also. Ano? Para silang constant t. So yun. Tapos this one, itong partial derivative of s with respect to p at constant t, um, ito yung hanapan natin ng Maxwell equivalent. So, ang Maxwell equivalent nito, ds dt, ito, no? Partial derivative of s with respect to p at constant t is equals to partial derivative of b with respect to t at constant p. So, this is the um, similar partial derivative equation in volume expansivity. So that's why nakita niyo doon sa final equation nagkaroon ng beta. Okay? Beta times B. Yun. So dito galing yun. Ano? So, balikan natin yung equation. So sabi ng Maxwell equation, partial derivative of S with respect to P at constant T is equals to negative, ano? Negative of this is equal to partial derivative of B with respect to temperature at constant P. Okay, so we just substitute this. And also this is equals to ano, this is also equal to beta volume expansivity times molar volume. Kaya naman ay specific volume, ano? Di ba? So, yun. So palitan lang natin ng BB yung dito. This is negative, ano, kasi may negative doon. So palitan lang natin to. So what you're going to get is partial derivative of h with respect to p at constant t is equals to t negative may negative, ano, negative t times bb plus b. So when you factor out b, you're going to get this part of the equation. Diba? If you factor out b, you're going to get 1 minus beta times temperature. Yun. Tapos times dp kasi may dp talaga dito sa ating equation. Ano? Ito yung dp na. Tapos pag in-integrate nyo, halimbawa, the liquid is incompressible, beta is constant, temperature is constant, usually yun yung initial, ano? Kasi pag nag-pump kayo ng liquid, hindi naman masyado nagbabago yung temperature nun. Konti lang yung change, yung delta T natin palagi mababa lang. So ina-assume lang na constant yung T for simplification of calculation. So, yun, basically magiging ganito na yung equation natin. Now, delta H, Cp delta T plus B 1 minus beta T times delta T. So usually delta T yung nawawala. So usually ito yung actual delta H, ano? So you can calculate this using the efficiency equation, 'di ba? The efficiency equation is delta HS divided by delta H. Ito yung delta H. So ito naman usually given ito sa problem. Tapos ito iso-solve natin. Tapos maso-solve yung delta H. Ito given din. Yan, given din yan. Beta is given. Temperature is usually yung initial temperature. Delta P is also given. Ano? Para ma-calculate nyo yung change in temperature. Usually, this is a very small number. Tapos, next, we're going to derive this. This is the formula for delta S. Actually, may Ln dito. Ano? Basically, ganun din naman yan. Let's clear this up. Ito, kasi basically yung ginagawa lang dito S, kamukha din nung kanina, ano, S, just assume that entropy is a function of temperature. Kita nyo naman dito, ano, and pressure. Ganun din lamang yan. So, if you're going to assume that entropy is a function of temperature and pressure, so ds is equals to partial derivative of S with respect to T at constant P times dt plus partial derivative of S with respect to T, constant T times dP. Basically, ganun din, no? Tapos itong kasi parang as you can see magka-cancel out lang naman to, di ba? Yung dt nito. So parang itong first term natin, parang ano lang yan, delta S, no? Parang delta S lang to pag nag-cancel to. Imagine niyo pag nag-cancel to. Di ba parang delta S lang naman. So ang delta S, ang formula natin ng delta S is simply Cp dt over T pag constant temperature, ano? Tapos integrate nyo to. So pag integrate niyan, you will have Cp ln T2 over T1. So ganun lang yung formula niyan, ano? Yung first term niya. Yung second term naman, ganun din. Papalitan nyo lamang yung delta S, yung partial derivative ng S with respect to P at constant temperature. Diba? If you still remember the Maxwell equation. Ito yung Maxwell equation natin. Diba? This is also equal dun sa partial derivative of P with respect to temperature at constant pressure. So this is also equal to BB, no? B beta times volume, molar volume or specific volume, no? So if you're going to replace this partial derivative of S with respect to P at constant temperature with negative BB, you will have this equation. Yun. Tapos, yun, gawin nyo lamang yung dP, gawin nyo lang delta P. Okay? So, yun, as long as you have the final temperature, if you can calculate the final temperature using the delta T from the delta H equation, delta T. Alam niyo na yung T2, T1. Given naman usually ang Cp at saka T1. Tapos may given naman na beta, specific volume, tsaka delta P. You can calculate that. Okay? Tapos, as I've said, you can also find this equation in chapter 4. So pakihanap na lang, pakihanap na lang sa chapter 4. Sigurado ako na sa 8th edition, chapter 4. Pakihanap na lang. Lumalabas sa board exam niya. Pumps. Okay, so let's try to solve a problem. So let's try to solve example 7.10. Water at 45 degrees Celsius and 10 kilopascal. It enters an adiabatic pump and is discharged at a pressure of 8,600 kPa. Okay. Assume the pump efficiency to be 0.75. As you can see, meron tayong given na efficiency, 0.75. And then, ang initial temperature niya, 45 degrees Celsius. Yun yung gagamitin natin temperature. Tapos, siyempre, a pump increases the pressure from 10 kPa to 8,600 kPa. So, calculate the work of the pump. So, in order to calculate WS, actual work yan, in order to calculate WS, basically what you're going to do is BDP lang, no? B delta P. So yan, kita nyo, may delta P naman, 8,600 tsaka 10 minus 10. Tapos yung B, ayan, sa baba. The following properties for saturated liquid at 45 degrees Celsius, 318.15 Kelvin is, ito yung B niya, 1,010 cubic centimeter per kilogram. That's 1,010 ml per kilogram. Ano? Ito yung beta. So ito yung gagamitin nyo sa B. Tapos ito yung delta P. So the temperature change of water. So in order to solve the temperature change of water, just use the delta H equation. Yung delta H is equals to Cp delta T, etc. No? To memorize. So pag kayo, tingnan nyo na rin lamang sa handout. Tapos entropy, pag na-calculate nyo na yung temperature change, just use the entropy equation. So first, you need to calculate T2, tapos calculate the entropy change of water. Tapos ito yung Cp, 4.178 kilojoules per kilogram per Kelvin. Okay, so I'm going to share a whiteboard. Medyo mahaba yung calculation. Basically, natandaan nyo naman yung given, meron tayong dalawang pressure, initial at saka final, tapos initial temperature, tapos 0.75 yung efficiency. Tapos given din yung specific volume, beta, at saka Cp. Let me share a whiteboard. Okay, so we're trying to solve example 7.10. So pump. So first, let's calculate delta HS. So the formula for delta HS is specific volume times the change in pressure. No? So it's given that the specific volume is 1010 cubic centimeter per kilogram. And then ang ating pressure change 8,600 kilopascal. So minus 10 kilopascal. So all you need to do here, you need to do some some conversion. So ito Newton per meter squared yung Pascal, di ba? So you need to convert this cubic centimeter into cubic meter. So pwedeng di ba kasi ml to ano? So pag ml yan, just pwedeng muna convert niyo muna sa liters, no? So divide niyo lamang siya ng 1,000, di ba, ml per liters. Tapos di ba there are 1,000 liters per cubic meter. Okay? So pag ganyan na yan, ang lalabas dyan na delta HS nyo ay kilojoules per kilogram na. No? So just use your calculator to find delta HS. This is actually delta HS. Ano pa to? No? WS isentropic pa lang to. So gagamitin nyo pa ng efficiency equation. Ano? So we're supposed to get something like 8,675.9 kilojoules per joules per kilogram. Pag ginawa niyo yung joules per kilogram, ibig sabihin nito ay I converted this K into times 10 to the 3 ano, o parang minultiply ko yung equation ng times 1,000. Pag ito lang yung pinindot niyo sa calculator, ang lalabas yan 8.675. Okay? So this is 8,590. As you can see, magka-cancel out ito. Tapos divided by 1,000. Pag kilojoules, this is 8.675 lang. Pag joules, 8,675. Okay? Pag ito, generally equal to 8.6759 kilojoules per kilogram. You can confirm this using your calculator. Pause nyo lang yung video nyo, tapos pindutin nyo sa calculator. Ito yung lalabas. No? Kung gusto nyo joules, ito, times nyo ng 1,000, ito yung lalabas. Okay? Tapos let's use the efficiency equation to calculate for delta H. Yung delta H equal na yun sa WS. Ano? So, yung delta HS nasa taas, mas maliit kasi ito. Yung delta H yung nasa ilalim. Tapos it's given na ang efficiency ng pump natin ay 0.75. Yung delta HS natin ay 8.6759 kilojoules per kilogram. Tapos divided by 0.7, this is delta H na. Okay? Delta H. Yun. So you're supposed to get something like your work, WS. Supposed to get something like 11.6 ano? Kilojoules per kilogram. So this is one of the final answer. Now, the next question is, you need to calculate the delta T, no? So, remember yung equation natin na delta H is equals to Cp delta T plus B 1 minus beta T times delta P. Yung delta H dito, yung actual. Ito. No? Ito yan. Yung delta H dyan. Yung una nyo na-calculate, delta HS yun. Remember, isentropic to. Ano? Isentropic tong 8.675. Ito yung delta H na ako. So just substitute the value. If you're going to use the 11.6 kilojoules per kilogram, tapos yung CP natin is given to be 4.178 kilojoules per kilogram Kelvin. So yung lalabas na delta T dito, ang unit niya, Kelvin. Ano? Yan yung first term. Ano? Compatible naman siya dito sa delta H units natin. Ano? Plus, yung given na ano na specific volume ay 1,010. This is the same as in cubic centimeter no, per kilogram. So just like before, you can convert this to cubic meter by simply dividing this by 1,000s. Ano? So the first 1,000 will convert this to liter. The second division by 1,000 will convert this to cubic meter. Or pwede nyo rin ba, para mabilis, lagay nyo lang divided by 1,000 squared. Ano? Tapos, so yun, okay na yung ano natin, yung V natin na. Tapos yung 1 minus na lang. 1 minus, ang beta is given to be 425 times 10 to the minus 6. So this is per Kelvin. Dapat para yung unit, ano? So yung temperature natin ay 318.15. Because ang initial temperature natin ay 45, ano? So 45 plus 273, 318. 318.15. So yun. Beta T, so wala nang unit yan. Tapos, just multiply this with delta P. So yung delta P natin, ito rin yan. Ano? So 8,590 kilopascal. So times, hindi na kasya doon na. Times 8,600 kilopascal minus 10 kilopascal. This is your delta P. So ang unit nito, this is cubic meter per kilogram, tapos kilopascal. So magiging ano rin to, ano, kilojoules per kilogram. So compatible naman yun. So just use sheep-solved function of your calculator and you should be able to get a delta T value of 0.98. Ito yung pangalawang requirement. Okay? So I'm going to clear this whiteboard to solve for delta S. So madali lang naman na puro formula lang. So we're still solving example 7.10. Tapos let's try to solve the delta S in a pump. So the formula is Cp ln T2 over T1. And then minus BB, beta B times delta P. Okay, so delta S is simply equal to 4.178. This is in kilojoules per kilogram per Kelvin. So yun na rin yung magiging unit niya ng ano no, ng delta S. Tapos Ln. So yung final temperature natin ay 45.98. Iinit siya ano pagdaan ng pump, generally umiinit siya. So para maging Kelvin, dapat Kelvin yung T2 plus 273.15. Yung initial natin ay 45. Kaya ito yung delta T, ano yung 0.98 plus 273.15. Tapos yung susunod na term, yung beta natin, ang beta natin ay 425 times 10 to the minus 6. Okay, per Kelvin. So, multiply nyo nung V, yung specific volume. It's 1,010 cubic centimeter. Ganun ulit, ano? Per kilogram. So, i-divide nyo ng dalawang 1,000 para maging cubic meter. Alam niyo na to, ano? Tapos yung delta P. Yung delta P natin ay the same pa rin, 8,590 kilopascal. Okay, so just use your calculator. Ito makikita nyo magiging ano rin to, no, kilojoules per kilogram Kelvin. Just use your calculator. You should be able to arrive at delta S is equals to 9.01 times 10 to the minus. So ang unit niya ay kilojoules per kilogram per Kelvin. Okay, so I hope you get these calculations. Formula lang naman. Let's go back to the PowerPoint. Let's confirm the answer from the book. Ito yung final answer from the book. So if you still remember, we have calculated the work. It's around 11.6. Ito, 11.57 kilojoules per kilogram. Tapos yung delta T natin, 0.98. Siya, 0.97. Okay, malapit naman. And then finally, yung delta S, ang siya ay 0.009. Tayo 9.01 times 10 to the minus 6 kilojoules per kilogram per kilogram. Okay, so parehas lang naman. Okay, so I'm going to leave you with an exercise sa Blackboard. So paki-solve na lang regarding pumps. No? Tapos on the next video, probably I'm going to discuss chapter 8, yung mga power cycles. So see you on the next video.